A traditional bamboo shelter relies entirely on friction and geometry. There are no metal fasteners here. Here is how it comes together. Building a shelter entirely from scratch begins with harvesting and moving the raw materials. Fresh bamboo is dense with moisture, making its transport a demanding physical process. He balances the heavy culms across the uneven terrain to the designated building site. Moving the timber in full lengths preserves the intact fibers, which provide the sheer tensile strength required for load-bearing posts. Working without machinery demands careful energy management, leveraging the shoulder as a pivot point against the unwieldy loads. Once staged at the clearing, the raw stalks are prepared for their structural roles. The transition from raw material handling to structural joinery demands a shift in precision. Traditional bamboo framing relies heavily on interlocking connections and friction, completely avoiding metal fasteners that would rust or degrade. He sizes a custom wooden support block to mate cleanly against the curved profile of the vertical post. Using a manual hand drill, he slowly bores a channel through the dense outer wall. Bamboo's longitudinal fibers provide significant strength, but they are highly susceptible to splitting if aggressively punctured. The hand auger cuts cleanly, extracting material without stressing the surrounding structure. Once the hole is established, a hardwood dowel is hammered into the void. This creates a permanent mechanical lock. As ambient humidity fluctuates, the wooden peg and the bamboo will expand and contract at different rates, essentially tightening the joint over time. Working exclusively with hand tools gives the builder critical tactile feedback. He feels the precise moment the peg seats flush. This method distributes weight loads evenly across the joint, ensuring the core frame can withstand heavy lateral forces. With the vertical supports established, horizontal crossbeams bridge the structural gaps. The beam drops into a pre-cut notch, transferring its downward weight directly into the vertical post, rather than relying solely on the peg. A small dowel locks the assembly, preventing any lateral shifting. He taps the timber gently into its final position to avoid bruising the fibers. Trimming the excess material flush is not just an aesthetic choice. Removing overhangs eliminates leverage points where accidental impacts could weaken the joint. As the primary frame scales upward, lifting the prepared beams requires careful alignment. He sets a heavy bamboo rail into the upper assembly, balancing the load across the foundational posts. Every connection up here dictates the true plumb and square of the finished shelter. He drills through the wooden crossmember, establishing a new tie-in point. Driving a heavy peg through this junction anchors the horizontal span to the primary uprights. The deep seating of the dowel provides high shear strength, locking the corner against twisting forces. A few solid strikes with the mallet secure the fit, locking the skeleton into a rigid, self-supporting frame. The structure gains its final height as the tall roof-bearing poles are hoisted into position. Standing these long uprights requires balancing the vertical load perfectly against the established base frame. He fastens a rigid wooden brace to hold the tall mast steady while the permanent joints are cut. Drilling through these temporary supports requires the same care as the main frame, ensuring the drill bit bites cleanly into the dense grain. Hammering the brace tight solidifies the preventing any dangerous sway while the upper tier is built. A flush cut finishes the joint. With the load-bearing skeleton complete, the focus turns to the enclosing walls. He aligns slender vertical poles to create the primary interior partition. Pushing against the uprights verifies their tension. A wall is only as strong as its flex resistance. By pressing his body weight into the assembly, he tests how the structure will respond to high winds. Minor adjustments ensure the poles sit perfectly plumb. He cuts a fresh set of wooden pegs to anchor the base rails. These bottom connections are vital to prevent the wall panels from kicking out under heavy loads. The hand plane shaves away the rough outer skin of the horizontal brace. Smoothing the surface removes irregularities that might trap moisture and accelerate rot, extending the lifespan of the timber. Once surfaced, he carries the beam to the main wall section. These horizontal rails act as structural ribs, locking the vertical poles together into a unified barrier. He sets the beam against the uprights, checking the horizontal level by eye. Driving a heavy anchor through the rail binds the intersecting poles. This grid pattern creates immense rigidity across the entire wall plane. securing the base of the wall to the foundation requires deep, precise anchoring. The hand auger cuts a wide bore through the bottom rail directly into the underlying support timber. He drives a long, tapered peg deep into the cavity to fuse the layers together. The structural integrity of the entire hut relies on this base connection remaining entirely rigid against ground shifts. Trimming the exposed joint with a machete clears away splintered fibers that could hold rainwater. A clean, flush cut sheds moisture naturally, protecting the wood. Inspecting the connections by hand reveals any subtle wobbles the eye might miss. The craftsman verifies that every peg sits flush. Clearing the workspace of leftover scraps makes room for the next phase. Working from within the partially enclosed space, he drives a heavy wooden peg to lock the mid-wall braces. Every hammer strike sends vibrations through the entire frame, naturally settling the interlocking pieces deeper into their carved notches. This repetitive process of drilling and pegging ensures that any localized stress is distributed throughout the building. The continuous rigid grid acts like a woven basket, highly resilient to twisting forces. The structure is steadily stiffening. The lower wall sections are filled in by stacking horizontal bamboo logs. He bores final anchor points to secure the heavy cladding to the uprights. Stacking the logs horizontally creates a dense, impenetrable barrier against the elements and local wildlife. He steps back to evaluate the alignment of the massive wall plane. The visual check ensures the heavy logs haven't bowed the vertical supports under their combined weight. The shelter is finally transforming from a skeletal frame into an enclosed refuge. With the solid walls in place, the window openings require dedicated framing to maintain structural strength. Cutting a large void into a load-bearing wall naturally introduces a weak point. To counter this, he installs rigid cross braces across the opening. He hammers a heavy peg into the upper lintel to lock the span. Measuring the diagonal support involves holding the timber in place and marking the exact intersection point. Hand sawing on the line guarantees a friction fit that requires no extra shims. The saw glides through the hollow core, dropping the waste piece cleanly. Trimming the edges slightly refines the final fit. These diagonal braces restore the shear strength lost to the open window frame. the heavy entrance header bridges the gap above the door, carrying the weight of the roof structure above the opening. He wrestles the thick pole into position, locking it into the vertical door jambs. This critical beam prevents the doorway from sagging under the compressive load of the thatch. Stepping outside, he surveys the defined threshold. The structural shell is fully realized, separating the harsh exterior from the protected interior. Not all structural problems can be solved with a saw alone. He takes a large utility knife to shave away the final millimeters of a tight-fitting pole. This fine-tuning is essential for components that must slide into restrictive sockets. Removing the hard outer enamel of the bamboo exposes the softer inner fibers, which will compress slightly as the joint is hammered together. The focus now shifts from the heavy foundational elements to precise architectural detailing. He uses the hand drill to bore a clean channel through a prepared segment of bamboo, beginning the assembly of a complex geometric insert. These intricate decorative pieces demand far tighter tolerances than the main structural logs. He arranges 4 carved segments into a square module, dry-fitting the interlocking corners. Even minor measurement deviations here will compound, throwing the entire pattern out of square. Satisfied with the alignment, he drives small wooden pins into the joints. The mallet strikes must be carefully controlled. Hitting the pegs too aggressively risks splitting the delicate outer walls of the shorter bamboo pieces. As the wooden dowels wedge deep into the voids, they draw the corner angles tightly together, locking the shape. He presses his weight against the frame, physically testing the rigidity of the assembly. The resulting square module will serve as both an intricate decorative element and a functional lattice to diffuse harsh incoming sunlight. Integrating the finished lattice into the solid wall requires carving dedicated receiver notches. The chisel bites deep into the vertical wall post, cutting a recessed socket to house the frame. Removing material from a load-bearing post must be done carefully to avoid compromising its vertical strength. The notch creates a flush resting place, ensuring the insert sits seamlessly against the wall plane. He taps the square frame into the freshly cut recess. The friction fit holds the module tightly, seamlessly blending the decorative lattice with the heavy structural wall. He continues populating the wall opening with additional geometric squares. Holding the small frame steady against the vertical post, he drives another retaining peg to lock it in place. These inserts transform a simple open void into a complex structural window. Pushing the frame firmly onto the protruding dowels requires sustained pressure to seat the joints completely. He adjusts the tension by hand, ensuring the square sits perfectly level. The lattice breaks up the prevailing wind while allowing light and air to pass freely into the structure. The complex geometric puzzle nears completion as the final lateral braces are driven home. He hammers a long peg into the upper horizontal beam, anchoring the entire lattice matrix to the primary wall frame. These interlocking squares and rectangles create a highly rigid web, stiffening the large window opening against shear forces. Stepping back, he inspects the alignment of the intricate bamboo pattern. Every vertical and horizontal line must run parallel to the main structural posts. A slight physical adjustment pushes the final upright perfectly plumb. The decorative insert is now fully integrated. It stands as a testament to precision handcraft, transforming a utilitarian shelter into a carefully considered architectural space. As daylight fades, the rhythm of the mallet continues in the dark. He drives the final stabilizing peg, locking the last structural joint of the day. He rests a hand against the wall, feeling the solid rigidity of the finished frame. A structure built from the land, relying only on geometry and raw effort, now stands complete. The shelter and the landscape operate as a single system, a quiet refuge built to endure.